Okay, in this video we're going to introduce systems of equations, and we're going to look at in this video how to write a system of equation using matrices. So previously we looked at the method for multiplying matrices. So for instance, if we have a 3 by 3 matrix with 7, 2, -1 in the first row, 0, 5, 4 in the second row, and -3, 6, and 2 in the third row, and we multiply that by a 3 by 1 matrix where we have a 2, a 1, and a 3 in the first column, then we end up with a 3 by 1 matrix that's 13 with 13, 17, and 6. So again, we have 3 by 3, so the number of columns in the first matrix is 3. The number of rows in the second matrix is 3, so we can multiply these together. Our answer is going to be a matrix with 3 rows and 1 column, so 13, 17, and 6 as our answer. So in this section, we're going to use matrix multiplication to solve a system of equations. A system of equations consists of 2 or more equations with 2 or more variables. So in previous math classes, you may have had an example like 2x plus 5y equals 8 and -7x minus 3y equals 9. And for this first one, we could graph each equation and find the intersection point. That's a solution to them. We could also solve one of these equations for a variable and then substitute it into the other equation. That's a method known as substitution. Or we could also do some addition, subtraction, and multiplication to get rid of one of the variables in these equations. That's known as elimination. So we had in that group there, we have graphing methods, substitution methods, and elimination methods. The graphing method be a little bit more difficult for something like this one down here that has 3 variables and 3 equations. And also the substitution method might be a little bit troublesome as well, although it could be solved using a combination of substitution and elimination, but it might be a little bit tricky. Here we're going to find a real quick way to solve any system of equations, no matter how many equations we have. So we can use matrix multiplication with the coefficients of the terms on the left-hand side to write a system of equation using matrices. So that first example of 2x plus 5y equals 8 and -7x minus 3y equals 9 becomes the matrix a 2 by 2 matrix with 2 and 5 in the first row, and then -7 and -3 in the second row. And then we multiply that by a 2 by 1 matrix with an x in the first row and a y in the second row. And that's going to equal a 2 by 1 matrix with an 8 in the first row and a 9 in the second. And again, just to see this played out, if we take 2 times x and then add it to 5 times y, we get our first equation. And we can set it equal to this first row in this answer, so 8. And then -7 times x plus -3 times y gives us the left side of our second equation, and that's going to equal the 9. So for our other one, it would be 4, -9, and 2. And then in the second row, we'd have -1 for x, a 0 for y, so we have to use 0 as a placeholder, and a 1 for the coefficient for z. And then in the third row, we have 3, 10, and -12. And the variables we're using are x, y, and z. And then on the right-hand side, we have 10, 15, and 0. So if you were to multiply these matrices on the left-hand side, you would see that you would get the left-hand side of the equations in that are above. So example 1, we're going to write each of the following as a system of equations using matrices. So in example A, we have the first equation is 4y plus z equals -1. And then our next equation, we have -4x minus 5y plus 5z equals 0. And then in our third equation, we have 6x plus 5y equals 25. So our first and third equations have some missing variables. We're going to have to fill those in with zeros. So you can think of the first equation as 0x plus 4y plus z equals -1. So that left-hand side would be 0, 4, and 1. Then the second equation, we have all coefficients for variables already, so -4, -5, and 5. And then our third equation, we're missing z, so we'd have a 6, a 5, and a 0. So again, this first column represents the coefficients for x, the second column represents the coefficients for y, and our third column represents the coefficients for z. So the variables, again, we're using our x, y, z, so we'll multiply this matrix by x, y, z, and we're going to get what's on the right-hand side, the -1, the 0, and the 25. All right, part B, we have x minus y equals -9 and -3x minus 4y equals -8. So our first column is going to be our coefficients for x's, which are 1 and -3 in the first column. And then our second column is going to be the coefficients for the y's, -1 and -4. And then we'll multiply that matrix by the matrix xy, and we get -9 and -8 on the right-hand side. All right, so that about does it for this video. Thanks for watching. I'll see you next time.